Hi everyone, my name is Dimitris. I am part of the Android team at Square, particularly working on the Square Register app. And today I'd like to talk to you about automated testing. This is a particularly interesting topic to talk about. There's a lot of stuff going on around this space. This is something that we've tried before a couple of years ago, but I think maybe it wasn't the right time. And so we're back again. So automated testing is about using special software for executing your tests. And this is going to apply to everything, including, and more importantly, the UI tests, which is what we're interested in here on Android. We want to be able to exercise in an automated way, going through a series of screens. So I'd like to start today with two terms that are really important around the Android in general at Square. And this is brand and quality. They play a very important role in what we're trying to do here. So on one hand, you have brand. This is the cognitive association users have with the products and services. So it sets the minimum expectations the users have for the products. And so when they're ready to download your app, they have a set of expectations and they love the brand. If you're a new app, you just released your app on the market, your users have no expectations. They just like the idea, maybe they've read it somewhere in a tech blog and they just want to use it and try it. So on the other hand, you have quality. This is something that you can measure. This is really important that you want to measure. And you can say something is of high quality or something is of low quality. For example, maybe you can define high quality around the number of crashes you have in your app. Or you could define quality as something that's made of really high-end materials. So you can measure this. So both of these are extremely important for us at Square because specifically for payments, there's not a lot of room for error. So to give you an example, if you swipe somebody's credit card, merchant, and it hands over the phone for the signature, and the app crashes, this leaves a very awkward moment for both sides. You swipe again, you refund the previous payment. Both merchant, what we call buyer and seller, they left it very. It's very important to keep the quality high, especially for every app that you build. And it goes very well with increasing your brand. So I'd like to talk about quality yesterday at Square. This is things that we've been doing, and we keep doing, but we're trying to move on to the next level. So it turns out that we don't really do something super fancy. This is probably something that everyone's doing here. It's a lot of manual testing. This includes, this happens in the form of like testing parties. That's what we call them internally. And it involves every single engineer coming in, or they're building a new feature, or they're testing a new version of the app, to test the app. This is very distracting. We ship at a very fast pace. We have weekly releases coming every 3 weeks, almost every month. And so we don't want to distract our engineers, and most importantly, we can't capture a lot of edge cases. With its manual testing, it can take you that far. So it's very difficult and very time-consuming for our team. The second thing that we do is a lot of unit testing. The team is really proud of this. We have 3,000 unit tests run for every pull request that gets open for Square. Very powerful. It's very nice to see the comments and pull requests from our team for asking members to write tests. We're very disciplined at that. And again, unit testing can take you that far. You have a lot of mocked objects that you deal with. You're not really testing closer to the real thing. So the last piece, this alphanumeric word string. This is really important. It's going to make sense in a second. This is one of the first commits that Eric Burke, our first Android engineer at Square, did back in 2010. So this is really important. This basically created the culture and the DNA that the Android team has today for testing, whether it's manual or automated testing. So it's very important to understand that culture and having your team work with tests is very important. If you don't, then most likely this process fails. So let's jump into quality today. What are we trying to do here and talk about? So quality today, we obviously need to adapt automated testing. But it has a lot of challenges. As I said earlier, we've tried to tackle this before. And it didn't work out first time. Maybe the tools weren't there, or expertise wasn't there. And this is great. Sorry for this. Really. Wow. Wow, I might have to wing you the actual slides running like this. Sorry for this. Yeah. Wow. Sorry for that, guys. Thank you. Max, right? We tried to do this before, and we came back again 2 years after. So as we got assigned, in order for us to deal with this, we needed to come as a team and pitch it as a product to our team. We needed to make sure that our team will adapt it, and they will actually want to use it. It wasn't some chore that we had to actually have. Bring somebody in like you only test. So what are the goals of this product? Public enemy number one, flakiness. Automated tests are notorious and have a very bad reputation regarding flakiness. If your tests are flaky, your team is not going to like this. They're going to think it's another joke they have to deal with. They're not going to trust the tests. And you're always going to have somebody who has to go fix the tests. That's a very boring process. So flakiness is something that we need to take into consideration as the number one goal. No flakiness. Second thing, testing to be easy to write. This applies to manual testing just as much to automated testing. And so, if your tests are easy to understand and read, then most likely your engineers will be willing to write new ones and also change the existing ones. If you make it very difficult for them, then they're going to have a really hard time to write new ones. So, one of the other goals is catch edge cases. Coming back to manual testing, this is very important. We want to be able to catch all the edge cases that people don't catch in manual testing. So we also don't want to have to remember these cases. And writing an automated test helps you have peace of mind that you tested. It helps you avoid these more crap moments that you might get when something ships. That, oh, we didn't test with a high font size that I have. Or we forgot some communication that we don't really test. Moving on to the next thing. So there's three types of testing methods. And it's black box testing, gray box testing, and white box testing. Each color depicts the amount of knowledge that the tester has for the internals of the target application. So black box testing means no visibility of the internals. This gives you as close to the real game testing as you need. It's literally your own user sitting down, has no idea, he just touches a few things and things magically happen. On the other hand, you have white box testing, which gives you full access to the internals of the app. We use that for unit testing, because we mock everything out, and then we give us the ability to change some of the internals of the app in order to create the stage for our test. And in the middle, you have gray box testing, which is like a balance between the two. It gives you some visibility in internals, but not everything. And of course, we chose to go gray box testing, and there's a reason for that. Number one, if you need to change the internals of the app in order to make your automated test pass, then you're doing it wrong. We don't want that. We don't want to start polluting our code base with test code and put conditionals in the code just to make sure that our test can pass. So, on the other hand, as I said earlier, we want to make sure that the tests are easy to write. And so by giving some visibility, such as your UIDs, your resources, and a few other things, you make it really easy for your developers to write the test. So this is the way we want to go. So this is a red circle. It might not make any sense yet, but you've seen this before many times. This is a red build on your CI. this is a red build of Jenkins or whichever build system you're using. And so, going back to the discipline, we want to make sure that as a team, we're very disciplined when master is red. If something goes on master, we have a policy that someone needs to go and fix it immediately, either by reverting the commit that caused the breakage, or by quickly applying a fix. We want master to always be shippable, because every time we want to do a release, we want to cut off the branch off the master. So we want to apply the exact same thing for automated tests here. If the tests become red and they're going to run in parallel build, because they take a long time to run, then we need to make sure that somebody goes in and fixes it. Assuming you have no flakiness, then somebody calls actual breakage, and somebody needs to go fix it. So discipline in your team is very important in succeeding in automated testing. So this word gets thrown around a lot. It doesn't mean in our case drones or physical mechanical robots that sit and actually take the test. But it's primarily a vehicle for us for writing tests. They serve a few purposes. The number one, they provide a very thin abstraction layer for every screen that we automate. So the Register app, we have a bunch of screens. Every screen has a robot that actually instruments that screen. So we provide an abstraction layer about the underlying framework that we use to instrument that screen. So in this case, we chose to use Espresso, which you guys are all familiar with, and I believe there's a talk for this as well. But it doesn't matter in our case. Robots help us change the underlying implementation of how we interact with UI in a sense that, like, to the test writer, it has no any significant difference. The second thing that robots do is they provide a fluent API. Because we actually have control of this, we can give you methods that you can interact with the screen in a fluent manner. This is really good about the readability of the test I was talking about earlier. To test that reading as a little scenario, as a little story that you can just read. I'll show you an example in a second. The third thing that robots do is they basically provide a single point in your code base that you have to update the code if something changes. So if you have a screen that you introduced brand new functionality, or maybe you removed something or added something new, all you have to do is go into the robot, change everything you need, and then you don't have to go and update 15 or 20 tests, which might be interacting with the same screen. So to show you an example, this is the robot for the invoice screen. We recently added support to send invoices on the Android client. This robot instruments the invoice screen. And it gives you a few helper methods when you're running a test to interact with that screen. So this is typing the title of the invoice, or clicking the send button. This is really cool. There's more there, but I'm just showing you only a small piece of it. So when you write the test, let's try this again. We have a static method that provides you the robot implementation. There's no reason why you can't instantiate it yourself. The static method performs a few implicit checks to make sure that you are where you are asking to be. And then as you can see, this is the actions that you perform on that screen. And if you read them, you don't have to know anything about the square code base to understand what this test is actually doing. Basically going in, filling in all the English info that it needs to do, and clicks the send button. The other thing that we do is between your tests and all the steps that you do, you can actually perform a session, which is what this is all about. So in this case, we assert that the button is disabled. It becomes again the ability to use all the IDs that you need. And then we perform the same amount of tests for typing all the info that an invoice needs. And then we make sure that the button was enabled before we can click it. This turns out to be really powerful. Again, it comes back to make your test look like a story. It's really easy to understand. So, the next thing to talk about is mod mode. This is a very powerful technique that we adopted about 2 or 3 years ago at Square. It turns out to be extremely powerful when it comes to automated testing. So, as we have all the devices plugged in, possibly in a USB plug, maybe CD, about 10 or 15 of them running our tests continuously, we realized that we had a lot of flakiness regarding the network. Devices were going on and off the network, the network itself was going down, something else was wrong, maybe a bad deploy and staging server, can't really take payments in production continuously, nice. But mod mode comes in and helps solve the problem of flakiness, and it also gives you a lot of power for automated tests. So let me show you how mod mode works. Number one, you've seen this before maybe. If you're using diagram retrofit, this is definitely familiar to you. This is providing a production binding for an implementation of the service that you use to perform network calls. It doesn't matter, you might have a different way of doing it, but this is a simplified of bits. Now, this is a production binary. This is possibly what you want to ship into a production version of the app. Now, if you have a dev flavor of the app, you should, if you don't, you can override that binary. What you can do is, alongside the real version of your service, you can actually provide more implementation of your service. You can feed that through a service proxy. So what a service proxy is, nothing more than an invocation app at runtime. We check if mock mode is on, and then we actually find out the implementation of the service that we want to invoke. This is immensely powerful for us. It's a very tiny trick. It doesn't take a long to add it, but effectively it makes mock mode as another endpoint that you can use your client to point to. So this is how the implementation of the mock service looks like. Just implements the interface, it provides all the calls. And then you can do anything you want with it. For example, we have an artificial delay. It's simulated with some network latency, and this would happen for network. And you can toy around with this a lot. You can increase the delay, reduce it, and everything more. The other great thing that this offers you is you can use multi-tier patterns to simulate scenarios that you don't usually test. This is really powerful because, for example, you can force mock-mode to throw network errors. I don't know if a lot of people, at least even on Square, sit down and actually test how does the app look like when there is network failure everywhere. And mock-mode can help you do that. You can even go a little bit more deep. You can provide some flakiness on your network. Maybe every other network call you actually get a bad response from the server. So it becomes extremely powerful to test in an automated way scenarios that otherwise you would never do it manually. So very useful for us. The next thing is a test matrix. This is a pretty interesting particular challenge to the Square. Let me show you an example of how to understand this. So in our app, we have a flow that we call the cardinal present flow. This provides you the ability to actually take a payment without swiping. Maybe your friend, you're on the phone with a friend, you want his credit card, or you don't have a reader with you, and you actually can type the friend's credit card number in order to charge him. So the cool thing about it is that we format every credit card number that you see you can type in depending on the type of the card. It's Visa, MasterCard, and so forth. So we've never, or I shouldn't say never, but we don't really often sit down and type every single type of credit card support on a manual text. This would be very cumbersome for the team to do. Most people just remember a Visa card and just type it in there and everything works. So let's look around all the test cases that can come up from this. First, we start with 7 credit card types. Visa, MasterCard, Discover Diners, Amex, and a couple more I don't remember. There are 7 significant credit card types. The next thing is we want to be able to test this for 4 languages. We support Japanese, French, English, and Spanish. So we want to make sure that this flow is exercised on all 4 different languages for all 7 cards. It doesn't end there. We also have 4 different receipt types. You can email receipt, SMS, decline it, or skip the receipt. So very quickly, you have a tremendous amount of tests that come in that you need to write for. You have 112 tests, and there's only 2 ways. There's 2 ways that come to my mind you can solve this. You can ask your engineers to sit down and do 112 test cases. You can watch them quit the company the next day, or you could literally copy-paste the test case in your test class. You can just start writing all of them together. So obviously this is a joke. But we felt like that we created a new tool that helps us fix this problem. And so I'd like to introduce to you today a new tool that we're open sourcing, and it's called Burst. This is a new library that we wrote internally specifically for that purpose. I believe Jake is all around right now for the live. So what does Burst do? Burst is a test generator. Basically, we use enums that generate all the different values and variations that you want to apply your tests. Most of you might be familiar with parameterized. Burst makes it a little bit easier for you. You can also combine multiple enums together to create the product of all the test cases you want to create. So in this case, we want an enum for all the credit card types, the different languages, and also the different receipt types. So the other thing that Burst offers you is variation proximity. You don't have to provide variations for all the test cases that you write your test plans. For example, you can provide variations at the constructor level, or you can provide variations at the method level. This becomes really powerful because you can choose which test you actually want, but you can also combine constructor level and method level variations together. So all in all, very quickly, you get the ability to cover this 112 test cases that we just talked about. Very quickly. You only have to write the flow once. You don't have to keep copy and pasting the test over and over again. The next thing we offer is type safety. Unlike parameterized, where you have to create iterable object arrays, which is very cumbersome, I'll show you in a second. Rest uses enums, and you can just provide a declarative, familiar way, in a very type-safe way for you to define the variations. This provides a very clean code in your test. You don't have a lot of setup things that you have to do. So the last thing is you can use burst everywhere. The core library actually doesn't really apply only for tests. You can use it for other means. We haven't come up with a way yet, but we'll give you the offer for that. So it's not just only for tests. So here's what burst is not. This is a typical test for parameterized. It doesn't matter if you can read all of it, that's the point of it. There's a lot of setup that you have to do in order for you to get a variation and parameterized test to go through. Most of all, if you provide multiple types of variations, in this case we only have one, for a factory. If you provide a second one, they have to be declared in the order that you provide them. This is just very cumbersome, we don't like this. So this is how it looks on burst. You basically create an enum that provides you with different variations. In this case, for this example, with sodas, a Coke, Pepsi, and Nasi Cola. And then you have your normal tests that you apply the burst test runner on it. What happens is you just pass in the enum on the test method itself, and if you run it, you will actually run this test 3 times because you provide 3 values for your enum. So this is very clean, this is very powerful. You can take it, as I said, to the next level. You have 2 enums, for example, for snacks, that you pass in, and you actually provide it to the test method again. What this is going to do is run the test 9 times for every permutation. So this is extremely powerful. The other thing that we offer is friendly test naming. The enums themselves and the values that they have provide a really cool way to provide a nice name for your test. It's very hard when you have 112 test cases for you to identify which of the permutations fail. If just, if the test name is always the same. To give it like a little bit simpler, you have, these are 3 out of the 9 months. And you can just imagine that the first and the third one actually pass. But the name itself includes the method and the variation values that you provide in the enum. So it's very easy and very powerful for engineers to find out which of the permutations might grow and why. They can very easily pinpoint. This is really important. It's really cool to see it happen. So on top of this, we also add some support for automated tests that reflect many configurations. You have tablets, landscape, phones, different sizes, you know how it is. And the process is we provide an annotation, we call tablet only, we also give you phone only annotation. If you put down your test, the best test runner is going to ignore the test if the device is not, if the device is not actually giving the configuration that you asked for. So the test at the top is going to run on your tablets, it's going to be skipped automatically for phones, and the complete opposite for the example below. So Burst is really cool, we're open sourcing it, we want to see what you guys can do. I'm really excited for this. Myself, and another engineer at Square actually wrote the first internal version, and then, of course, we had to enlist Jake in order to get it out for open source, and it's really great. So, if you put up the tests, this is how everything can look like. This is a normal test that exercises a very specific edge case on the score register, which is you charge something at $24.99, the tip that you add takes you just slightly over the $25 mark, and then you have to ask for the user to sign. So, I don't think a lot of our engineers actually sit down and test that, we just trust that it works. But now we have a test that can actually run the automated way, and we have a peace of mind for this. You can see interact with all the robots, everything that we need, perform a lot of actions, and reach to the end result that we need. Let's go on to the next. So, I'd like to bring in some tips around automated testing that we found out as we were doing this process. So, the first thing is animations off. This is pretty self-explanatory. If you want to make sure that your tests are not super flaky, you're not really exactly testing the real thing to turn them off, but in the name of reducing flakiness, this is a very well advice to apply. So you can turn them off multiple ways. We don't have to cover them right now, but turn them off no matter what for your tests. Second, don't sleep. If you find yourself adding a lot of threads before actions on the UI, something is wrong. This is hopefully what your underlying library, such as Espresso, will take care for you. If you see yourself already like, oh, I'm going to have to add sleep, or I need to wait a little bit just enough for something to happen, then you're setting up yourself for some flakiness. So every time you see this is really bad for us. We try to avoid sleeping as much as we can. This is a really important, perhaps one of my favorite parts that automated tests give you. Screenshots. You can really have some really powerful results from screenshots just by executing your tests. So as you walk and traverse through your flows, you can take a screenshot for every single action that you take. Here's a way that we come up with. We haven't applied it yet, but I believe it's really cool. First of all, actually, I want to cover another thing. Sorry. Espresso gives you the ability to provide venue handling. This is something you can just override and provide some additional functionality when one of your automated tests fails. So the added is custom venue handler. It basically takes the current test case that's running, and if it fails, it uploads and sends us a screenshot, either via email or a chat channel. This is extremely helpful for us to know that the test is flaky, provides us a snapshot, screenshot if you will, about what happened when the test failed. Was there a dialogue that we didn't expect showing up? Was there something else? Did actually something break? So it's really cool to see that coming in and you're able to figure out why did the test break and be able to get a snapshot of what happened at that time. The way you do it is providing the value handler that Espresso offers you. You just take and upload the screenshot whatever you need based on the test name, and then you delegate to the real value handler. So the next thing that you can do, which is really cool, is provide a screenshot proxy, similar to what we did for Lockmode. Screenshot proxy can use so you don't have to have your testers run for every step that they take a screenshot. If you remember the previous example that I gave you for robots, there were a lot of steps that happened during the invoice test. So what if we could just automate that and take for every step and every action we perform in the UI and grab a screenshot to see how it is? So what you do is you feed in the robots right before they invoke into a screenshot proxy that basically invokes the real method. So basically we just type anything that needs to happen on screen, then takes a screenshot and stores that. So every step that you perform, you can see what happened. And most of all, you don't have to have your engineers remember to add like screenshot support in every single test case. This makes me sad. The keyboard on Android, you guys are probably familiar both with API, but also automated tests becomes like a very big nightmare. So the keyboard runs in a separate process. So this is the only time that maybe you have to use sleep and hope for the best. Most of the time, you'll see me try to interact with the keyboard is up and running, you'll get a security exception from Android for injecting an event to a separate process that you're allowed to. That's because the keyboard is signed with a different key. So typically, if you see that happen, then something should be with the keyboard. There's two ways you can solve this. Number one, turn the keyboard off, which is fine. It reduces the flakiness, but you're not really testing your app how it should look like. The keyboard sometimes will actually rearrange the layout and give you important information about how your app reacts. The other way, which is what we end up doing, is literally sleeping. And hopefully is the only exception that we have to provide here in order to reduce the keyboard performance. So, this slide has a double meaning. First of all, just like screenshots, there's no reason why you can't leverage your test in order to take a video. This is really powerful. KitKat added support for this, and I highly recommend you use it. But I also want to take some time to show you this whole thing and how it looks like. It's just a 30-second video, and it runs on a tablet, landscape, and a portrait. This is how automated tests look like when they run. It's a little bit fast. But it actually exercises what the UI was talking about. This actually is powered by bursts, and it will go on forever. So this is really cool to actually see happening. This actually creates a lot of confidence for our team and a high quality that we want to have. So this is going to keep going actually forever. I have done 30 seconds. We test every single flow we have to take the payment. In no way, we try to actually apply variations with bursts for the data that we want to test. So that's all I have for you today. This is a new ground for us. I'm glad to speak with you for anything else that we might have, what you're doing for this. Really excited that we actually broke some ground for this and we have a new library that we like open source. And I'm really hopeful that we push the envelope a little bit forward for automated testing. I'll take any questions right now. the question was about Spoon. It was another open source library we had specifically for that reason. Spoon was actually a pen that we had 2 or 3 years ago, and by revisiting this, we're actually going to revisit Spoon. So we're aiming to increase the value of Spoon and actually release an update for it. But this is something that we're just working on right now. Yes, so the question was if we have a device lab and our own set of devices. We do. We have an actual device lab literally. We have a lot of hundreds of Android devices. We recently started supporting Android, so that's a big win. But then yes, the goal is to actually have a device for Android lab and plug in all the devices and run all the tests to just solve briefly. We buy every single device that comes, brand new device that comes in, we're first to test it for swiping and every other thing that we need to test. Question was mentioned. So this is really cool. I haven't come up I haven't actually tackled it all yet, but there's no reason why we can't. Another thing that I actually forgot to mention is once you get the screenshots, you can actually use them for some OCR, post processing. You can actually figure out the strings that belong to specific screens. You can feed that to your translators, and very easily they can just start searching and finding out which screen a string belongs to. So this can turn out a very powerful tool for them. You can actually take screenshots for every single language, and so you can actually see how your app looks like in all the languages you support. If something wraps, or if something doesn't fit, something gets edited. So definitely we're looking at that for both getting a data screenshots and also providing helpful tools for our translators. How is it to change them in terms of so the question was about how do we handle the annotation for tablet only and phone only. And as new devices come in, it's having a blurred line between the size of the devices. So we actually have a cutoff point with the smallest width of 600 dB for settings tablets that Android gives you, and everything that uses that, it's immediately a tablet. So, but there's no reason why you couldn't provide your own more granular annotations. They help you force something to run on a device if you consider it a tablet or consider it like a phone, perhaps. Yes, so far they're pretty simple. Just to say. Any other questions? I see it. Oh, sorry. Yes. How do you do it? Oh, so mock mode is the answer to that. Mock mode, in order for us to wait, we actually use Espresso. We have sort of a black box technique for waiting for all the progress bars to go away. We don't actually wait or plug into the actual network thread that performs the operation. We tend to go black box style for this. We just make sure that there's no progress bar showing up on the screen. But mock mode definitely helps you. Even with mock mode, we can even plug in easier to all network calls, make sure that they're done before we continue the test. And you can expand mock mode. Yes? So the question was if we have any test specific for handling different types of rendering for hardware and software. Oh, interesting. We haven't done something yet with overdrop, but that would be a cool way to even apply for screenshots. Maybe you can enable overdrop mode. You can just grab a screenshot and see how your app looks like on the screen where you're actually doing a bad job of overdrop. That's a pretty cool idea, actually. But we haven't done something specifically yet. So one more question, if there's any. Oh, yep.
You mentioned the robot stuff up there.
No, we're not open source analysis, it's just an internal technique that we use. There's no reason why you can adapt it, but it's not part of Burst. So the question was if the robot stuff that we're doing is part of Burst and we're open source. And the answer is no, but they're very simple to write. It's a very thin abstraction layer of your framework. All right, that's all I have. Thanks, guys.